Hello everybody, welcome back to our final video for section 1.2 arithmetic series. This is a neat example, example number 6. It says determine the arithmetic series which has partial sums. So partial sums, it just shows us that we have the sum of the first four terms is 26, the sum of the first five terms is 40, and the sum of the first six terms is 57. So I'm going to show you two methods today. The first method I will show you algebraically, and then the second one is we'll just do a little bit of logic and determining what's next. So some people can figure this out, like I said, with logic. I'm going to show you how to do a 2x2 system first, algebraically, because sometimes they are not in this order, right? So here we notice that the sum is the fourth, fifth, and sixth term, so this makes it a little easier. But sometimes you will get a question where it's the sum of the, let's say the fourth term, seventh term, and ninth term. So it doesn't follow that pattern. So there's two methods that can be involved here, like I said. So the first one I'm going to use one that's going to work all the time, and then the second one for this particular example I'll show you if you were just to use logic how you could solve this question. So the first one here is we're going to use the formula, the sum n equals n bracket 2 times t1 plus t bracket n minus 1 all divided by 2. And this will allow us to put in n, because we know n is going to be 4. We know the whole thing is going to be equal to 26. And then we can just solve through. So again, I'll do that with you here. So we have the sum of four terms is equal to 4. So we have the n 4. T1 we don't know, d we don't know, but we know this is 4, so it's going to be 4 minus 1. Now the whole thing, remember, sum of 4 is equal to 26, so we can replace that with 26. Remember, n is 4. That'll simplify to 4 minus 1, which is 3, which would be 3d at the beginning. I can take the 4 and divide it by the 2. That'll get rid of the fraction, so that'll be 2 here. So taking 4 divided by 2 would end up giving us 2 times t1 plus 3d. I'll simplify it, right? Because we take the 4 divided by 2, and that would give us a 2 out in front, right here. And then the 2 was already with the t1, and then the 4 minus 1, which would give us 3 times d, which is 3d. So that's what we end up with. And we can further simplify that if we want to multiply that out. Well, instead of multiplying 2, I'll just divide by the 2. Take 26 divided by 2. So divide on both sides, because the 2 is multiplied by everything in brackets. So if we divide this by 2, 2 divided by 2 is equal to 1, which is gone, and then 26 divided by there. So there's our first equation for our 2x2 system. Now you can pick either one here. I'll just pick the next one just because it's right there. Like I said, it doesn't matter. So now we'll do for the fifth one. So the fifth would equal, so anywhere we see n, we put 5 instead of 4. That's the only thing that's going to be different here. It's going to be 5. All right, and then we'll substitute in what we know and simplify here. And we end up with the fifth term, which is 40. And of course that was 5 divided by 2, so that would be actually 2 decimal 5, and then 4d, 2t1 plus 4d. All right, and again we can divide that out. So we'll recopy this. All right, and then we'll take each side and divide it by 2 decimal 5. So when we take 40 and divide it by 2 decimal 5, we get 40 divided by 2 decimal 5, we get 16. So now we divide both sides by 2 decimal 5, divide both sides by 2 decimal 5, we get 16. And again, you can lose the brackets now. Once we've divided that out, the brackets can be removed. And then we have two equations. Now we have a 2x2 system. So what we're going to do is we'll take the second equation and subtract the first. That'll just keep everything positive. Again, it doesn't matter the order in which you do that. So we take the first equation, all right, and we subtract the second equation. All right, so subtract, and remember everything's in brackets just because you're subtracting everything. All right, I'll put that overline, just underline that. So we're taking the first equation, subtracting the second equation, so we're using what's called elimination. And we call it elimination, and you'll see in a minute why. So 16 subtract 13 would be 3. 2t subtract 2t would be 0t. 1, which is gone, that's why we did it. And 4d subtract 3d would be d. So that tells you that the common difference for this is going to be 3 using elimination. All right? So once you have the, that is 3, then you can put that back in and find the first term. You can put it in either equation if you want. And I'll take this here, and we get there. So 13. And then we change our d to 3 because we just calculated, and that'll give us 13 plus 2t, and then 3 times 3 is 9. Subtract the 9 from both sides. We subtract 9. 9 subtract 9 is 0, and 13 subtract 9 would be 4. Divide both sides by 2, and divide that by 2 is 1. And divide 4 by 2 and you get 2. So that means the first term in the sequence is 2, and we know that the difference is 1, so it says determine the arithmetic series which has these partial sums. The arithmetic series for these partial sums would be 2 plus 5, because the difference is 3, plus 8, plus 11. If you add those up there, you'll notice that 2 plus 11 is 7, plus 8 is 15, plus 11 is 26, so it does hold true. Then we add the 3 more, which would be 14. 14 plus 26 again is 40, plus plus 17 would be 57, and so on. We don't know where it ends because we weren't sure. So there is your answer. It says determine the arithmetic series which has these partial sums, and that is this. If it's stopping at 6, it would be just 6. That's fine, but it doesn't really tell us, but that would be the arithmetic series in infinite, right? We just continue to keep adding 3, and so on. So that is using your like the system of equations, right? But you could also use logic. Okay. We could just use logic. Some people would have said, okay, well, if I know the sum of the first 4 terms is 26, and I know that the sum of the first 5 terms is, is 40, well, that tells me that the 5th term is going to be 14. So I'll show you what I mean by that. So if I'm looking for the 5th term, all I need to do is take the sum of first 5 terms, subtract sum of the first 4 terms, and that will give me the difference, which actually is the 5th term. Now again, some people may not write it with all the proper notation, but I like to show where it's exactly coming from. So I'll just add those terms in there. Sorry. There we go, it's better. 40 subtract 26, and I'm not sure why it's doing that, and that'd be 14. So, which makes sense. If the sum of the first 4 terms is 26, and the sum of the first 5 terms is 40, then the only difference between the 2 is the 5th term. It's equal to 14. So that gives you T5. T5 is 14. And then you can do the same for the next 2. So if you're looking for the 6th term, that's just going to be the sum of the 6 terms minus the sum of the 5 terms, right? And that has to be consecutive. Again, this method's is really only going to work due to the fact that we have consecutive sums. We will need to use this method here if the sums were consecutive. So again, this is just logic based on what information we had, right? Which would be, what do we have? We had 57, subtract 40, and that would give us a total of 17. Right? So now if we know 2 consecutive terms, we know the difference, right? Because the difference is simply going to be equal to term 6 minus term 5, which is the definition of common difference for these for an arithmetic sequence. So 17 minus 14. That gives us a common difference of 3, which we have here, right? So then you can just work backwards if you want, right? So we know that it's 17, right? We have 17 as the 6th term, so the one before that. Work backwards is 14, that's the 5th term. Working back to get the 4th term would be 11. Working back to get the 3rd term would be 8. And working backwards, that gives 5. And then continuing to work backwards for the 1st term would be 2. So, again, obtaining the arithmetic series for the given information. Right? Again, just an alternative method. Not always going to work, but a great method given the information that you have. So that concludes our 1.2. You'll notice the homework here. It's on page 27 of your textbook, numbers 1 through 6, 9 through 11, and 15. Please work on those questions, and if you have any questions at all, please let me know. Any feedback, again, is appreciated. I hope you're enjoying the videos. It's just another resource for you in case you miss time for whatever reason. You have the ability to work, and it's going to give us some extra time to do some problems in class. I think that's the goal. So definitely get some feedback on this, and we'll go from there. So thanks again, and we'll see you in the next video on 1.3, geometric sequence. Bye for now.